Hello everyone and welcome to yet another recreation programming session with Mr. Zozin. So today we're doing an offline session, so there will be no chat or anything like that. And today I want to continue developing digital music looper that we developed, that we started to develop on the previous session. So as of right now, we don't really have much. We have a very simple synthesizer and also a very simple recorder of the events of the synthesizer. So it looks like that, right? So it does a little bit of a clicking, right? So to match the BPM, you can press some keys to synthesize sine waves. Yeah, I think they're hearable. Right, so you can press several of them to have chords and stuff like that. But there is a kind of like a fundamental flaw in their sounding is that they're very clippy. You see, at the end of the notes, they're kind of like, you know, clicking a little bit, and that's because they actually start very sudden and end very sudden. To combat that, usually in audio programming, people implement something called ADSR, which is attack, decay, sustain, release, and essentially it's basically the volume. I wish we could actually kind of, I'm sorry for flash banging, but like there's nothing much I can do about it, I think. So the idea in here is that you don't start at the volume 100, you start at the volume 0 and you ramp it up over some period of time. Maybe I can actually something like that. It's kind of like the contrast is a little bit like low, but I think it's, you can see that. So essentially you start at the volume 0 and you start ramping it up to 100, right? Then you decay it a little bit. And then you sustain it until you release your key, and then you basically release it, right? So it decays into 0 again. So, and this is what we want to implement, right? So we don't want to start the notes very suddenly. We want to, you know, smooth them a little bit in terms of volume. Yeah, let's go ahead and try to implement that because I think it's kind of an important part of the synthesizer, right? So otherwise, it sounds kind of meh in my opinion. So let me see what we have in here. So essentially, there's this function called note update, which accepts the frame count, the current frame count, and so the frame is basically a sample, right? So it refers to the same units when we're referring to sample rate being, you know, 48,000 or 44,000 and stuff like that, right? So this kind of sample rate, and this is the current sample. In audio, people call them frames, sometimes they call them samples. I think in case of the frames, some people mean basically a pair of samples for left and right ear when we talk about stereo and stuff like that. For some reason I decided to call them frame count. So frequency is basically in hertz, right? So what's the frequency of the note we're currently playing, and that's the global frame count. The amplitude basically defines the volume, right? So because when we update the note, we want to actually play it maybe a little bit lower because we're mixing several notes and stuff like that. So that's what we're passing in here. And we're also accepting the buffer. So and what this function is supposed to do, given the current frame count, frequency, and amplitude, it basically have to fill in the buffer, right? So as you can see, it offsets the frame count accordingly and fills up the buffer. So that's basically what this function does. But I feel like, so we have to refactor this function a little bit because essentially we're updating nodes in these chunks, and the size of the chunk is this buffer. If we take a look at where we call this function, we're passing the buffer in here, and the buffer is defined as an array of 2048 samples, right? So that means we can kind of, you know, update the nodes in chunks of this specific buffer. I would like to maybe refactor our approach a little bit. Instead of accepting the buffer, right, let's actually return the current float. Right, so the current sample for that specific frame count, right, so for that specific frame count, and get rid of that loop entirely. Right, so that way we don't really have to even offset the current frame count, we just use the current frame count, and we simply return this entire thing. So, and essentially what we're doing with this function is we're saying that give me the sample for that specific frame count, global frame count, for that specific frequency at that specific amplitude. We can maybe even get rid of the amplitude. I think this is kind of an interesting, get rid of the amplitude, and whoever calls that function should apply the amplitude to that sample themselves, right? So that makes it a very simple formula. Let's maybe go and try to compile the entire thing. So this is where we're doing all of that stuff. And what we're doing in here is that we're iterating two arrays in parallel. So there's two arrays in here, nodes monitor and nodes replay. And the size of this arrays is the amount of keys on the keyboard that we mapped specifically to the nodes, right? And this each individual sort of index of that array represents the semitone. So, and essentially Boolean indicates that the node is currently playing. So, and what we're doing is when we're synthesizing things, we're iterating these two arrays in parallel, see what node is currently playing, and we're kind of mixing that into the final buffer and stuff like that. So I'm not really sure if that's a good approach to do it like that. So the reason why we have two of such arrays is because we have two sources of the sound. The monitor, it's when you press the key and you hear something back. I'm not sure if I can actually, you know, demonstrate that. I need to stash my changes, right? So this is the, you can hear the monitor right now, but then you can actually record some things, right? And then you're replaying, and this is currently replay playing, right? I can play simultaneously with replay. So there's two sources of sound, replay and monitor. So, and that's why there's two arrays in here. That's basically what it all means. So the thing I don't particularly like about how it is currently implemented is that we kind of iterate these two arrays in parallel, and we look, okay, if any of the nodes are currently pressed, just play that semitone. Just play that semitone. I really like this approach, honestly. I would like to maybe, if both of the sources of the sound play the same note, well, yeah, just mix them as separate nodes. I think that would make a little bit more sense. So here, when the buffer is processed, when the audio stream is processed, we are preparing the buffer of samples to give it to the synthesizer. We're cleaning up the buffer, we set everything to 0. Then we need to count how many nodes are currently playing. So to do that, I'm gonna actually cross out this entire thing. I'm iterating nodes monitor, and if the node is currently playing, I'm actually incrementing the amount of nodes that is currently playing, right? Maybe I'm gonna even, I can actually turn that into like a single line in here, right? So, and then for the replay, I kind of do the same thing. So, and I feel like this is much better approach, right? So we are counting how many nodes are playing across both of the sources of the sound. That's what we're doing in here. And if we do have some nodes playing, we're again iterating these two sources of the sound in parallel, and if any of them is playing, we're playing the note. I want to get rid of that. So what I want is I'm iterating one source in here, nodes monitor for instance, and if it is currently playing, I'm playing that specific node. So do I have the changes? Yeah, so I do have the changes. So what I do in here, so this is amplitude we're talking about, right? So this is amplitude. I moved it out of this entire function. This is the buffer. And what are we feeling in here? I suppose what we're feeling in here is the current frame. So that means maybe we can do something like frame count plus equals, but I don't feel like this is the right thing to do, because frame count is, yeah, it can overflow in shit. It can actually overflow. So what I'm thinking is that maybe we should go even further. Forget everything that I put below in here. And we need to update maybe the entirety of the buffer. Let's actually iterate the buffer, right? Iterate the buffer. and say that I want to mix the current sample, right? I want to mix the current sample. What's interesting is that, so as we're going to be varying the volume of the nodes, some nodes may actually stop playing in the middle of the buffer that we're currently filling in. So that means we have to count how many nodes are currently playing on each individual sample of the buffer that we're actually filling in. So this is where it has to be, I think, right? So we're iterating through the buffer that we need to fill in to give to the stream. Then on each sample of that buffer, we're counting how many nodes are currently playing, right? So how many nodes are currently playing. And then we, I guess, need to do this thing in here. So for the first source of the sound, right? For the first source of the sound. So the amplitude is going to be kind of the same, I think, for all of them in here, which also means that we can have a division by 0 in here. So we need to do something like that. So there could be a division by 0. Then, so if it is plane, we are multiplying this by amplitude. I feel like I need to say, okay, I'm iterating the samples of the buffer. I'm iterating the samples of the buffer, and I'm actually adding this to the samples of the buffer, which also means that we can clean the buffer as we're filling it in. So this condition doesn't make much sense anymore, by the way. This condition doesn't make much sense. Right, so we can, okay, so this restructuring is actually rather interesting. So we can move this logic inside in here, right? So we're cleaning up the samples as we're iterating the current sample. We're setting that sample to 0. On that specific sample, we're counting how many nodes are playing on that specific sample. If any of the nodes are playing, we're iterating the monitor nodes. If that current node is playing, we are adding that sample in here. Then we need to do the second thing for the replay source. Right, if something is playing in here, we're adding that to the samples. And then we can also move that logic inside after we computed the current sample. So we can say that clamp the current sample to -1 and 1. And I think that is basically it, except on each iteration, we also need to advance the frame count. Right, so that kind of like a complete inversion of what I was doing before. First I was iterating nodes and then I was iterating each samples, but now I'm iterating each sample in an outer loop, and for each sample I'm iterating each individual node to mix everything in. So it's kind of an inversion of this entire thing, but I feel like it will allow me to actually gradually change the volume of the nodes as I'm iterating them. So it's a little bit more flexible in that regard. And that's the entirety of the logic, right? So we need to fill in the audio buffer. We iterate each individual sample, and for each individual sample, we know how many nodes are currently playing, right? So, and we're just mixing everything in. So that's kind of a better, like I should have implemented it right away like that in the previous session. But I mean, so we're kind of exploring. It's not always obvious how to do the right solution. Okay. I need to take off my headphones because who knows what kind of mistakes I've made. So the audio programming is very dangerous, right? So generally the audio programming is probably one of the most dangerous areas of programming, because if you're not careful, one wrong float and you don't have your ears anymore. So let's try to press the key. Okay, so everything seems to be fine. If I mix in several notes, all right, everything is Gucci, everything is Tamaguchi. All right, all right, all right. So now we can try to maybe start doing more interesting stuff. I feel like, so here we only keep track of the information whether the node is playing or not playing, but this is not particularly enough information for us to implement the attack and decay and release and stuff like that. What I wanna do instead is I wanna add the additional information probably when the node started playing, so we know for how long it's been playing already. So I want to introduce maybe something like structure node, right, and it's going to contain things like playing, so whether it is currently playing, and we also need to know when it started playing. So we were discussing in the Discord server and also in the Twitch chat different approaches to how we want to keep track of when it started playing. Maybe use timestamp or something like that. I want to try to actually keep track of the current frame count, right? So something, maybe call it like timestamp frame stamp, right? It's like the current frame, the global frame it started to play at. And I wonder if it makes sense or not, but I want to try something like that. So now each individual node array, each individual sound source is basically an array of nodes, right? So that's what we're doing in here. And effectively, so we want to have like a bunch of functions in here. The function that starts the node, it starts the nodes. You accept node by a pointer, and you also accept the current frame count. So it's not going to be probably doing anything particularly special, except maybe setting playing to true and the frame stamp to frame count. I would like to maybe rename playing to underscore, so everywhere everywhere where I'm trying to modify playing directly, it's already broken, so I don't really have to modify that. So I was hoping to break every place where I'm referring to this thing, but I'm already referring to it through the array directly, so nothing needs to be done in here. So node stop, and I'm going to maybe accept this kind of stuff, and now it is going to be false. It will be also nice to know when the node stopped playing, because we're going to be decaying the node, but I'm going to keep that for a little bit later. So I'm going to go and just try to recompile the whole thing. So this is when we are replaying the events, right? So this is when we are replaying the events, and what we're doing in here is that each event also contains whether the node is playing or the node is stopped. So what we have to do instead of this assignment, we have to check, is it a start? Right, is it a start? And if it is a start, we have to do node play. Right, so this is the node play, we're replaying the node, and then here we have to stop the node. There we go. And that stuff is not needed anymore. So node play accepts the frame count as well. So the frame count is kind of a semi-global variable, right? It's inside of main, but it's kind of global for the current, sort of like an event loop. If that makes any sense. Okay, so this is the monitor, and we are replaying the monitor. So what we're checking in here, whether the current node is playing or not, right? And if it is playing, we're recording that as an event and blah, blah, blah. So now, when we are replaying things, so what we're doing in here, apparently we're stopping all of the nodes. So maybe that's exactly what we need to do, node stop, and I just have to provide node in here. Might as well maybe call it like that, so it looks a little bit better. Look at that, I'm iterating nodes replay. I'm not sure, I'm gonna keep the curly braces like that in here. All right, what else do we have in here? So if not playing, we start playing, node play, like so. We also need to keep track of the current count. Right, and so not playing, that's right. And this one has to be probably playing, and we stop playing, node stop. We stop the node like that. All right, what else do we have in here? This one is interesting. So this is playing, right? This is the recent code that we introduced, and this one is okay. So yeah, this is playing, and this is playing. All right. So I'm gonna take off my headphones. Hopefully everything's fine. Everything's fine. Okay, great, great, great. So, since we know for how long we've been actually playing the node, we can do some interesting stuff, especially when we do the node update. Node update, as of right now, it doesn't accept the node itself that is currently playing, right? And I explicitly removed that in the previous session, but I suppose it was a mistake. We want to kind of bring that back. Right, so I'm going to maybe accept the node by a pointer. And let's actually go to the compilation. Do I want to go to the compilations right now or maybe a little bit later? Let's do that a little bit later. So essentially, we know when it started to play, frame stamp. So, and we take the frame count and we subtract the frame stamp, and this is for how many frames the node has been playing. So we can introduce something like attack frames, and this is basically for how many frames the attack should actually go, basically for how many frames it should rise up to 100%. So we can say maybe for, if the current frame rate is 48,000, right, let's say maybe thousands of the frames, let's make it 10,000, so it's a fourth of a second, so we can clearly hear the attack. It's a little bit too long of an attack, but I want it to be long because I want to be able to hear it. So I take the distance in frames, the duration of the node in frame, and I divide it by the attack frames. That is an integer division, which is not particularly good. What we want to do in here, we want to cast it to float, so the entire division is in float, so that means this entire value is from 0 to 1, and that is basically our volume. Right, and because the node can last longer than the attack, this entire thing is going to go beyond 1, all right, so, but we need to clamp it to 1. Let's say that we're looking for the minimum between that value and 1, so it's never going to be bigger than 1. We cut it out at 1. And here we can just multiply by that volume. It's so difficult for me to pronounce that. That's like basically it, right? So that's basically an attack. So yeah, let's see how it's gonna go. So we're gonna have a bunch of compilation errors, right? So because now we need to put the node in here. Maybe it makes sense to iterate the nodes by a pointer like that. And this is the node. This is the node. And this is kind of like a semitone. Let's actually call this index a semitone. Semitone. It's almost like a semicolon, but it's a semitone. Spent 3 hours jamming, and it was a single missing semitone. Okay, anyways, I'm sorry. And this one is also going to be node semitone. So node is playing, and this is a semitone. Freaking Emacs! Fuck you, Emacs. Yeah, this is what I want. Yeah, and this one also has to be the node. So frame count. Okay. Take off my headphones. Be very fucking careful when you do audio, any kind of audio programming. Never test new things with the headphones on. I made that mistake once, never making that mistake ever again. I think I heard an attack. Wait a second. So it ends abruptly. It does in fact end abruptly, but it starts very smooth. Okay, so that's pretty good. Well, something's wrong with sine wave a little bit. It's kind of crunchy for some reason, so there's definitely some sort of a bug in there, but I'm not sure what exactly that is, so let's actually continue pushing. So I'm not sure if I want to do the decay and then sustain. Let's have a simpler version on today's session where we just have like a attack and sustain, and that's it. And then when you unpress the key, we're kind of like releasing it automatically. So the problem here, okay, with the release, and it's a very annoying problem, is that when you released, so we set playing to false, right? We set playing to false, but it needs to continue playing, right? And in a synthesizer, we have this nodes playing, and we measure how many nodes are currently playing by whether the playing flag is set to true or false. But when you unpress, it's immediately set to false, and nothing is playing anymore, so we can't really do this release properly, and I'm not even sure how to do that. So one thing I'm thinking about is maybe introduce some sort of a notion of released nodes, right? So here is the arrays of the nodes by their semitone and stuff like that, but we can maybe introduce something like another source of the sound. Maybe decaying nodes is going to be third source of the sound, right? So nodes decay, it's not really decay, it's released, right? So these are the released nodes, but this one I suppose is going to be a dynamic array, right? So because you can, yeah, it should be probably maybe a set, but we don't really have sets in Jive. There's a hash maps. We can put all that stuff into a hash map. But anyway, so these are kind of like a decaying nodes. And these are going to be the nodes when you stop playing the node, I suppose, right? When you stop playing it. And it feels like this has to be a separate structure, so to speak. Node released. Not the prettiest code, to be honest. Not the prettiest code, but that's kind of the code. If it works, I guess that's fine. So what we need in here is like when the node's starting playing, like it's a frame stamp, the classical frame stamp, and it's going to be an integer. And since it doesn't have any information about the current semitone it is playing, maybe we need to keep track of the semitone. Or maybe we could actually keep the frequency, because who said that we can't decay in terms of frequencies as well? And the frequency is, in our case, is a float, right? So that's the kind of the current frequency. When you, you know, press the node and then you release it. So we release a specific node at specific frequency. Actually, what if we call these functions node press and node release? And on top of this node being released, it sets playing to false. What it also does, it actually appends the release node to nodes released, right? So it's going to be array add nodes released, and in here, what do we do? We need to have a frame stamp, which is currently frame count, and the only way we can get the frame count is by a parameter in here. So this is a frame count, and it's going to be an integer. And the frequency, I'm not even sure what's going to be the frequency. We don't really have a frequency set in here. I suppose we'll have to accept that frequency. I'm starting to feel like that even the regular nodes should have their frequency attached to them. That's what I'm starting to say, but we're getting the frequency out of the position within the array, so I'm not 100% sure. So we're gonna keep refactoring this code until it kind of makes sense. It's the only reason why, like, it doesn't make sense much is because I'm not really sure how to solve the problem that we encounter, right? So it's sort of like a research. So a release, so we have a frame stamp and also we have a frequency, and we need to save that specific frequency in here, right? So we're saving the frequency and stuff like that. So it's not playing anymore, but it also released as well. It also makes sense, like if it was never playing though, right? If it was never playing, maybe we should never release it. So if it is not playing, just return. Or maybe make it a little bit more sort of obvious like that. But what if it was released in the middle of an attack? So you have to decrease its... So maybe one way we can do all of that stuff is we also store the volume of the node that was there when you release that node, and that volume is basically this. Right, so that's the current volume, and we set that volume like this, so when we're decaying that released node, not really decaying, but when we're releasing that node, we know like from which volume to start, like, you know, lowering it. So what's the opposite of rise? Lower, I suppose, but lower feels like something about the pitch, but here we're talking about volume. Silencing, I suppose. Silencing, I suppose. Okay, so let's go to the compilation errors, because I'm pretty sure there's a few compilation errors in here. So we also maybe want to introduce something like a release frame. And it's going to be, let's also say it's 10,000 or something. All right, so node Okay, press, right, we're pressing the node, and now we are releasing the node, and we also need to supply the current frame count, and so what else do we have in here? I didn't like something, I'm not quite sure, didn't I call it? Not enough argument, wanted 3. Oh, you have to provide the frequency, and yeah, we can get the frequency, so semitone to frequency, yeah, so essentially we do semitone to frequency, and we provide the semitone, semitone like that, and it's an integer, right? Or is it not? Event, well, I mean, the compiler will tell me. The compiler will tell me if something, yeah, so it needs to be integer, so I'm gonna x that mother flipper. So this one is a release, right? So this is a release. We have to provide, what was that? So frequency is rather easy. So semitone, semitone to frequency, XX semitone, and then frame count. That's the current frame count in here. All right, so node press. So we just go into the compilation. There's nothing particular special. Node release. So where was the, maybe I can copy paste semitone to frequency. Okay, so, and a semitone is it index. Is that a good idea? I feel like, okay, I want to actually use semitone in here. I kind of like it to be called semitone instead of it index. Semitone, all right, that's much better. Cool. So release semitone frequency and also frame count. I'm still not sure if frame count is good timestamp for what we're doing, but it is what it is. Okay, so right now it's not going to be releasing properly or anything, but that's fine, right? So because we now need to implement the synthesizing for the release nodes, right? So now we need to include the release nodes into the generation of all of that stuff. Okay, so how many nodes are playing is nodes of the monitor, nodes of the replay, and now for nodes released, so these are the release nodes, and if the node is playing, all right, and how do we know that it is playing? Well, it basically exists in the array. So which means, by the way, that we can just say nodes playing plus nodes released count. So that's how many nodes we have in here. Right. So, and if any nodes are currently playing, so we're iterating the monitor, the iterating the replay, and now on top of that we have to iterate the nodes released. Right. So this is the nodes released. And we know that the node is playing because it is within the array, and we need to mix it into this entire stuff. So yeah, that's a little bit of annoying, right? So node update. So node update is for just a regular node, so that means we need to node released update. We can probably implement that. So node released update, and essentially it accepts the node released. And what does it do? It returns this sample. Let's actually say that this entire thing returns the sample, and this entire thing returns the sample, like that. And yeah, volume is going to be rather freaking interesting, man. It's going to be rather freaking interesting. So this is how much frames have passed since the node was released. We have to divide, I think attack is actually double K. How do you spell attack? So, I don't remember. Oh my god, it doesn't even show that. Yes, double T. Okay, I made a little bit of a fucky-wacky, but that's besides the point, whatever. So, release frame. Right, so this is basically the value that goes from 0 to 1 up until the end of the release cycle, right? Can you see, like, I'm trying to scroll down and it only pops up this entire thing. Absolutely fucking useless. But what I'm trying to say is, so as we go from here to here, that value is actually from 0 to 1, and we're clamping it up to 1, which is totally fine. This is exactly what we want to do. But we actually want the volume to go from bigger value to smaller value. So because of that, I suppose we want to do -1. But then we might have actually started release the node at a very specific volume. So the actual volume that we need to have in here is node volume, right? Because as we release the node, maybe there was a particular volume of that node, so we want to actually start releasing that volume at that specific value. And after that, we're just generating a sample in here. So we also need a frame count. Right, so we need a frame count integer. We probably don't need a frequency because it is within the node. Right, it is within the node. Yeah, I think that's basically what we want to do in here. Let me go to all of that. So attack, I just modified the name of this thing. So another attack. What else do we have in here? Nodes release. Okay, so this one is a node. We pass it like that. So in terms of a semitone, yeah, we don't need that stuff anymore. So node released update. We probably don't need that stuff anymore. Okay, I'm not going to be playing anything because this is not enough. This is not enough yet. We now need to start really removing the nodes that are irrelevant, right? That the one that are kind of decayed. So we want to have maybe some sort of a function that answers a very simple question. Node released done, and it accepts the node released and returns basically is it done or not. So, and when is it done? It's when this value becomes bigger or equal to the release frame. So that's what we want to do. So this is done. And now we need to actually delete that node from the array of the nodes. This one is going to be interesting because we could use, so deleting a value out of the array is O of n, right? So it's a linear time, but there is a trick to delete a value from the array in O of 1, right? So for instance, if I want to delete C, so what I can do is that I can swap that C with the last element, and then I can pop out that value at the end of the array, which is usually O of 1. So if you don't care about the order of the elements of the array, you can remove elements from the array in O of 1. And I feel like this is our case. And by the way, as far as I know, Jai does have a function to do that. So I think it was unordered, yeah, array remove. Unordered remove by value. So there's other unordered by index. So this is what I want to do actually. So because of that, we probably have to iterate this thing in a maybe reversed order because, yeah. So for instance, I know that I want to delete things like B and D to remove like that. And if I start iterating this entire stuff, like I know the indices that I want to delete. Okay, so I'm not... Well, I know specific things I want to delete, right? I want specific things that I want to delete. It's located at B and D. So this is B, is going to be E, B, and we remove that. But what if I also wanted to remove like the last element as well? But now it is E. So this is not going to work. So I feel like what I have to do, right, I have to start deleting them in a reversed order. So I'm iterating it in a reversed order. Okay, so here is the D. I swap it with E and I removed that. So then another one is this, I swap it with B and I remove that. So, and if one of the things that I need to delete is E, right, is E, since I'm iterating all of these things in reversed order, so I very quickly just delete that. So then D is also going to be automatically removed. Then this thing is going to be swapped. Yeah, so I feel like if we're going to be doing an ordered remove, you have to iterate those things in a reversed order. So how are we going to be doing that? So we processed the buffer. And by the way, the node may stop playing. The node may stop playing actually on a current frame. Maybe because of that, we have to evict the released nodes as we're counting how many nodes we're currently playing. I think this is a kind of a cool idea if you think about it. So I'm iterating the nodes released. Nodes released. Do I iterate them by value or not? Okay, so this is going to be node, and then we're going to have an index. And I'm iterating all of that in a reversed order. And by the way, does it affect the index? I want to double check that. Just a second. Fuji. This one is going to be something like that. Let's say axis is going to be 69 for 2137, 885, and so on and so forth. So if I do something like axis, right, and then I'm just importing basic like that, this is going to be something like this. So this is X, and there we go. Not well, this is not really what I wanted, Borovsky. I wanted to do something like that, and I probably now need to also do auto run because it's a completely different system. And this is supposed to be %. Okay, so this is the things. And then in here, I can have an index. So this is basically I. And I can put stuff like this in here. Right, so this is the, yeah. And then I say, okay, iterate it in a reversed order. So that also reverses the index. Perfect. So this is everything I want you to know. Cool. As I'm iterating this thing in a reversed order, and then I know that node released is done, right? So this is the node, and if it is done, right, if it is done, what I'm effectively doing is I'm deleting it from the array. So array in order delete by the index, it accepts the pointer to the array. So in our case, it's going to be nodes released. And also we specify the index, so we just delete this entire thing. Otherwise, so the thing is currently playing, I'm just incrementing it by 1, and there you go. So we're simultaneously counting how many sort of decaying nodes are playing, and also removing them, evicting them out of the system. And that's basically it, I think. So here we're going to have an attack and we're going to have a release. We're not going to have a decay, even though we can introduce decay. I don't think it's that important, but yeah. So we can introduce that a little bit later. Okay, so let me see what we have. So this is a frame count. So when you release the thing, we also need to know what is the current frame count. Maybe it should become like a global thing, but we're gonna do that a little bit later. Note, is it called something differently? Did I call it something differently? Notes released. So there is a D at the end of this entire thing. Okay, that's pretty cool. Not enough arguments, not really done, because it also wants to have the current frame count. Does it want? Yeah, it does want to have like a current frame count. So this is another case of D. All right, I'm taking off my headphones, chat. I'm taking off, and I'm pressing the C. I'm pressing it. Did it work? Wait. I think it worked. Other node. Something is weirdly clipping, but at least there's a attack and then release. Yeah, there's something weird going on. I suspect that it has something to do with the fact that amplitude changes immediately as we are changing the amount of currently playing node. Right, so the way we currently mixing nodes together, is that we are, mixing them in equal proportions. But from what I heard, at least what Twitch chat told me, is that mixing like several sounds is actually a whole its own formula that depends on like human perception and stuff like that. I would like to make that maybe a completely separate session. One thing I maybe want to do, I want to explore how SDL mixer does that. Right, so in SDL, right, there's a sound subsystem, but it doesn't really mix anything. Right, so for mixing sounds, there is a SDL mixer, so audio mixer that supports various file formats for SDL and stuff like that. It will be kind of cool to look inside of this library and see how it does mixing of different sounds. So yeah, and I feel like my hypothesis so far is that this additional clipping, it's due to how we mix things, right? So because as soon as you press the second note, now notes playing is 2, right? And because of that, the amplitude with which we're mixing things is like shifts very quickly, and because of that, it feels like there's a clipping a little bit in here. So, but if you play on the level of like individual notes, it attacks smoothly and it decays smoothly. So that was pretty cool, I think. So yeah, I wonder if I wanna. We're just streaming for 45 minutes. You know what? Maybe I wanna make a small break. And after the break, we may want to try to look into the SDL mixer. Hopefully it's not going to take too much time. Well, we can actually get rid of the entire weighting of these things completely and essentially say that amplitude for all of them is going to be 1. We're mixing them with equal proportions. But I feel like it immediately will start sounding really weird as soon as you press the second note. Okay, I'm pressing the second note. There you go. Because it kind of like overflows and start clipping and stuff like that. So it just like sounds really, really weird. Something I initially wanted to try, like immediately wanted to try, is again, mix everything as is and then normalize it within the buffer. But I think now I see that it's not going to work, right? Now I see that it's not going to work. All right, so what I want to do, I want to make a small break. I want to refill my cup of tea. And after the small break, I'm going to maybe try to look into the SDL mixer, right? So even if I won't exactly copy it, I'm not sure if I want to even copy it, but if I'm not going to exactly copy it, maybe I will find some links to some sources, like where to read about the formula on how to mix things. I remember that Twitch chat told me about something like about A weighting. So A weighting is a form of frequency weighting in the most commonly used of a family of curves defined by the international standard, blah 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 blah. So there is some sort of a weighting of the things when you mixing stuff up, but I'm not sure how much I can trust that. So this is just like people told me that randomly in the chat, and it also has like a really scary formula, but it's not really that scary. So all the scariness are coming from the division and the square root, so it just looks big, but apart from that, it actually seems to be very simple, just like a lot of magical numbers in here. I suppose all of these magical numbers are kind of like a parameters of the human perception of the sound. But I want to look into how like SDL mixer does that. And if I find references to A weighting in the SDL mixer, I think that's the right way to go about it then. All right, so let's make some break, and we're back. As I was making a cup of tea, I just realized that I don't really even need to look into SDL mixer per se, because Raylib probably does the same stuff as well. Raylib, when you do something like play sound, it may play several sounds. That means it mixes them at some point, somehow. And maybe we can look into the source code of Raylib instead. Besides, I do have a source code of Raylib because for this specific project, I build from the source code. And we can start with the literally play sound. I wonder if I can find, can I use C tags? I think it's going to be actually very convenient. Find all the files with like the name that ends with ch, right? So find all of them and just feed them into e tags. Well, in Emacs it's called e tags, not c tags, but I mean kind of the same shit. So tags. So here they are, and what I want to find in here, maybe I can even do helm find e tags. Yeah, e tags select. Is it going to work? Okay, so can I find play sound? Holy shit, who needs the LSP? Come on. All right, so play the audio buffer. Okay, that's pretty cool. Play the audio buffer. Inside playing of the audio buffer, what do we do? So, all right, we log the audio, then buffer is playing, whether it's paused, it's not paused anymore, frame current pause. Not quite sure, like, okay, but what do we do with that? So I suppose there's some sort of a global array of audio buffers. So play an audio buffer is restarted to the start. Okay, so that's what it means. So that means the point to the audio buffer is also stored somewhere globally, right? So here is the sound, it's a stream, it's a buffer. We can actually look inside of there. Yeah, so the audio stream, and from the point of view of the user, it feels like it might be an opaque thing, right? It might be an opaque thing, but from the point of view of Raylib, it is something. Okay, so let's go back to the play sound. So here it is, audio buffer. I'm gonna go in here, all right. And then the audio subsystem. Okay, so I have a hypothesis that inside of the audio subsystem, there is something. So this is the audio data. I feel like I need to, yeah, okay, so audio data. It is defined somewhere here. Yes, so point to the first audio buffer. So you're telling me this is like a linked list of buffers. That's what it is. Audio data, so this is a system and stuff like that. So first and last, and the audio buffer itself, define audio buffer, it's a R audio buffer, and within this entire thing, so does it have, yeah, it does, it has Ray sound. You're using linked list to store audio buffers? Okay, I guess. That's a bit bizarre, but I do not judge. Maybe the real... Why not then? Okay, so one advantage of linked list over dynamic arrays is that you can take pointers to the things in that list, right? So one of the main problems with dynamic arrays is that the elements of dynamic arrays are constantly reallocated every time you push into the dynamic array, so you can't really reliably take a point inside of the dynamic array. Maybe that's kind of the point of using linked lists in here. And so, yeah, I guess that's the main point. So, but anyways, so here's the audio data. I wonder where this thing is used. We can probably find where it is used by modifying it, maybe. All right, so then trying to recompile Raylib. We can recompile Raylib by just, like, you know, generating the Raylib bindings one more time. So, and here are all of the places where all of that stuff is used. So let's go through them. I wish... That's a bit annoying, not gonna lie. That's a bit annoying. But majority of the changes are within our audio, which means that it's rather easy to just, you know, manually go through all of that. So this one is understandable, nothing interesting. Another one is 755. Okay, so track audio buffer to link list next position. Okay. So here they are, and we're just tracking them. Nothing particularly interesting. 755, 758, right, 762. Yeah, so all of that is just tracking them. 772 untrack. What does it even mean? Tracking and untracking. So 755. So track the audio buffer to linked list next. So we're locking the mutex, right? So because it's a global sort of variable, shared variable, and all right. So if the first is null, so this is the first one. Okay, so something about tracking it, but I'm not quite sure what's that supposed to mean. What I'm looking for, by the way, and this is probably where it is, so in somewhere in thousands, right, is where we mix in the audio for these buffers. So this one is rather interesting. So this is a load audio stream, nothing particularly special, just loading the audio stream. Audio buffer, and this is 714. So down below, this one is also rather interesting. I feel like this is where it is, but I want to actually first check 2250. Yeah, so set. Oh, this one is interesting. So I set audio stream buffer set default. I think we use that, but I think we use that for audio streams. But I mean, it says basically audio stream, isn't it? So 2569. Let's go here. What is this function? On send audio data to device. I think this is what we're interested in actually. So because it sounds like a function that is called before sending to the device. Sending audio data to device callback function. This function will be called when mini audio needs more data. Okay, that's basically all the mixing takes place in here. There you go. We found it. We fucking found it. Okay, this is great. This is great. So the frames out. Yeah, so this is the output. We are iterating each an individual buffer. Okay. This is great. Read audio frames in mixing format. Damn, broski. Mixed audio frames. Hell yeah, brother. Hell yeah. This is literally the place where all of that is happening. Like, holy shit. So read audio buffer frames in mixing format. Read audio data from an audio buffer object in device format. Return data will be in a format appropriate for mixing. What does it even mean? So what's so special about appropriate mixing? Curiously converting data from audio buffer internal format to mixing format, in which should be... Is that like... Yeah. Internal format could be like, I don't know, 16 bits integer, and mixing format is like a float. Maybe that's what it is. So MDA convert process PC. Okay. So this is what they use for converting this kind of stuff, and PCM frames I suppose is gonna be in floats, but I don't see floats. I see UIT64. Okay, let's maybe assume that we don't really care what's that mixing format or whatever. So what we're interested in is probably more is mix audio frames. So main mixing function, pretty simple in this project, only an accumulation. Parameter is both an input and output. It is initially filled with zeros outside of this function. Okay, so output, frames in, frame count, and this is an audio buffer. So considering panning and stuff like that. So, okay, there's some levels, and this is rather interesting. Okay, so they're just accumulating frames as is. Nothing really super fancy, except they're doing something special with the levels, depending on the panning and stuff like that. Depending on the panning. But I'm really curious. So there's a local volume. Okay, that's totally fine. There's channels, panning like left and right and so on and so forth. I feel like we're... So fast sign approximation for pan. We're not really doing panning, at least right now. So because of that, I'm not really sure what's up with all of that. And as of right now, our entire thing is mono, so this is not applicable to us. Maybe I will just, you know, skip all of that stuff. Yeah, this is what kind of surprises me, is that it's literally just an accumulator and doesn't even account for anything particularly special, just like adds things together. But then how does it normalize all of that stuff? Right, so we're just iterating and we're just mixing all of that stuff. Just iterating and just mixing. But then what else do we do with the frames? What else do we do with the frames? Do we do anything particularly special with them? I didn't think so. The only difference I see so far is that Raysan doesn't really clamp anything. That's the thing. Okay. So Raysan doesn't really clamp anything. The way we do that when we're mixing things and stuff, where is our mixer, is that we add everything, right? So, and we do have this, you know, floating point stuff, but then I decided, okay, so I'm going to clamp to -1 and 1. And that is probably what produces this, like a very square wavish sound, so like a very sharp sound, is because you basically create a square wave, right? So if you have a sine wave that exceeds this range of -1 and 1, you basically get a square wave. Maybe that's what I have to do, like just don't clamp. But if the samples exceed the range of -1 and 1, does it not do anything bad in terms of sound? Like, I thought it has to be exactly from -1 and 1. So what is it going to do? Is it going to make it just louder? So I thought something special required in here, but Raysan doesn't do anything, right? So he just adds the samples together and that's it, and calls it a day, at least from what I understood from his code. We can try to do that as well. Sure, let's just accumulate everything. Let's just accumulate everything and don't clamp, right? So just do not clamp, just do not clamp. And I wonder if it's going to solve it. Like, I hope it's not going to be too loud. Yeah, okay, so I probably need to change, like get rid of this change in here. So I'm regenerating Raylib, even though it's not required, right? I didn't make any particular changes to Raylib, but I'm regenerating bindings anyway, because I already started. So, and in here, so let's take a look at the application, and that application is first.jai, and let me try to run the whole thing. Okay, so I'm not wearing any headphones. I'm monitoring the level in the OBS. I'm pressing Z. That's cool. I'm pressing the 2 notes simultaneously. And it's fine, so that means they can exceed -1, 1. Why did I think they cannot? Why on earth I thought they cannot exceed -1 and 1? Am I stupid? And of course, that clipping problem, it went away. Though now there's a little bit of problem, is that they stack up so much that like the volume grows, not really exponentially, but it just grows so much. Maybe I'm gonna do some sort of adjustment of global volume the more we have nodes, but it also has to be like a very sort of, you know, how to say that, very smooth, so not to again introduce this weird problem of clipping. But in any case, I can just play things, and it kind of works, though it sounds a bit crunchy. I'm not really sure why. So what happened in here? Something is very crunchy happening, and is that because of the size of the buffer? I can increase the size of the buffer. Yeah, that was because of the size of the buffer. All right. It sounds like flute, you know? What I notice is that flute somehow produces, like, it's a natural instrument that somehow produces the closest wave to sine wave. And because of that, pure sine wave kind of sounds like flute. And I think it's one of the reasons why in chiptune artists approximate flute with sine wave. All right, I think I'm gonna call it a day. So that was great. Just like I learned the thing by looking into the source code of Raylib, and yeah, that was nice. I guess that's it for the day. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all on the next recreation programming session with Mr. Azuzin. I love you.